Okay, hi everybody, and welcome back to What's on the Bench with me, Martin Elsey of Tribes of Europe and Skeleton Hand. And this week this time we're going back to 1962, and we're dreaming of the race into space. Yep, we're travelling back to 1962. Kennedy had declared that we were going to put a man on the moon by the end of the decade. LSD still stood for pounds, shillings and pence. And Burns of London produced the Orbit 2. 45-watt all transistor guitar amplifier. That'll do for now, I think, for that. There we go. Right, okay, so transistor amplifiers. So for guitars, as guitarists, we all know that transistor amplifiers are a load of crap, don't we? And that valves are king. And that why would anybody ever be interested in making a transistor guitar amp? Well, for lots of reasons actually. You've got to remember we're going back to a time here that is pre-Eric Clapton, is pre-Jimi Hendrix. Nobody had really worked out how to kind of harness the musicality of distortion, or to harness it in a musical way. That's probably a better way of putting it. And people wanted clean. They wanted clean. You're talking about 1962, so we're talking about surf music. We're talking about the Shadows. We want those stinging, needle sharp, incisive highs and twangs. We're way before Dave Davis, taking a razor to the cones on his speakers and creating that sound for, You Really Got Me. Distortion, we're talking about a time where in the UK anyway, recording engineers still wore white coats and ties, and had tea breaks and stuff like that. That's where we are. Everything's clean, the pop's clean, everybody's called Bobby V, Bobby, can't think of anybody else called Bobby now anyway. But it seems like everybody's called Bobby, everybody's, hopping and bopping at the sock hop ball and drinking sody pops and, having milkshakes and stuff. And a transistor amp seemed like a really good idea, because the thing about valve amps, around this time you've got the AC30, you've got the Watkins have got various things on the go. The Westminster certainly would have, was out by now, been out for several years. They're valve amps, obviously. The thing about valve amps is they're not very linear. Basically, as you turn them up louder, they distort more and more. There's not like a kind of sudden cut over with them either. They gradually, as you get louder with them, the distortion increases and increases, And people, really didn't want that at the time. They wanted an amp that was loud but clean. Fender obviously could do this quite well with the, their, like the twin reverb. Very hard to get it to distort, But the thing is, it weighed a ton, and valves also tended to burn out quite quickly. Not just in the Fenders. In any valve amp. They're not the most efficient way of producing audio power, is basically the story. Transistors are a much more efficient way of producing audio power. So and that led to greater reliability. It led to a lighter amplifier as well. I mean, laughably, they'd stick a, there's like a handle on top of an AC30, there's a handle on top of a Fender Twin, but if you've ever tried lifting one, you know that the handle is a bit of a joke. So, an all transistor amplifier was a serious, taken very seriously, everything was going over to transistors then. You had the first transistor radios come out. The transistor, it was a sign of the future, That's what we're talking about here. And people did seriously, get down to, to Denmark Street, chuck in their AC30s, buy one of these or its predecessor, rather predictably, the Orbit 1. And there was also a follow-up to this as well, which is also a transistor, inevitably called the Orbit 3. So yeah, people generally did trade in their old valve amps and buy these tranny amps. Anyway, we're gonna have a listen to it in a while. Let's just have a quick look around it. So, intriguingly, you still got that kind of AC30 idea here of having the kind of control panel sort of at the back, if you know what I mean. And if you come around the front, we've got this kind of nice sort of TV front, if you like, nice sort of logo and stuff there. And then you have to sort of look over the top, and you get the usual thing of emulov, your volume markings and everything being backwards. So anyway, I tell you what, let's have enough. That's enough chat for now. Let's take it out of his overcoat. Ooh, and I'll meet you in a second or two, and we'll have a look at what it looks like inside. Okay. Ooh, see you in a while. Bye. Ooh. Ooh. So here we are. We've got the chassis out of the enclosure now, and we can have a good look at it. I've secured it in this high quality harness, bespoke harness here, so it doesn't slide around too much. It all remains safe, and I've given it a nice bath in some solvents to wash off all the old dirt, or some of it anyway. Just left enough dirt on there to keep its mojo. And in the bottom here we got some vintage dirt, so any people looking for that vintage tone, I can sell you some of this vintage dirt if you'd like that. Sprint that in the back of your DSP model and amplifiers, Anyway, so what we got here, here's a big AC step down transformer. So your mains electricity, which is alternating current, that's current that's changing direction every 20 milliseconds, 50 times a second, at high voltage. That comes in. That's the kind of most efficient way of moving electricity around. That's why you have that. Anyway, it may be efficient for moving electricity around, but it's no good for running electronic circuits. They need, particularly transistor circuits, they need relatively low voltage direct current, so current that's just moving in one direction. Anyway, you have this transformer that drops the AC down from, in this case it drops it down from about we're in the UK, so it drops it down from 240 volts to around about 35, something like that. It's still AC at that point, so you've got to turn it into DC. And this is kind of where it gets sort of interesting, I think. We've got this device in here, and you'll find this in all modern amps as well, tranny or valve, and it's called a it's a full wave semiconductor bridge rectifier. Okay, there are 4 semiconductor diodes inside this, in this case made out of a substance called germanium. And what this does is it turns that alternating current, it stops it from flopping backwards and forwards like that, and turns it into flat direct current. Alright, this is very important. Previously this job would have been done by valves, okay, and in high-end amplifiers today you sometimes find that they're still using valves for this job. Now the point is that when you do this rectification process, you lose some volts across the rectifier. Now semiconductors do this very linearly, it's very predictable, and it doesn't change that much depending on how much power you're trying to pull. So the point is that when you hit a note on one of these old tranny amps, these rectifiers just keep delivering the current that's needed, alright, and the volts that are needed, and so you get this needle sharp attack to the start of the note. Now on the old valve amps that still had valves in this this position here, they tended to fold back a bit. They drop volts and they throttle the current a bit, so that you get what you call sag at the start of a note or a chord when you hit it. And this is a very important part of what's termed the valve sound, you know. In fact, these days pretty much everybody's switched over to using these silicon rectifiers or semiconductor rectifiers for this this process, but they still recreate the effect of sag by putting some big resistors in the circuit as well that kind of recreates that sagging effect. So even on like a Marshall, you find you've got a semiconductor rectifier, but it's it still gets that sag through using these big resistors. There's circuitry in there to kind of recreate basically that sagging effect, because it's seen as being a very musical part of it. It's the thing that kind of gives you that sort of that crunch and warmth as you kind of hit a big chord on an overdriven you know, an amp that's really, an old valve amp that's really turned up. So anyway, yeah, a little bit there on the semiconductor rectifier. Coming out of that, you've got some smoothing caps that just take some of that ripple out of the rectified signal, rectified voltage, rectified supply, and then we're into the actual amp stages. And here we've got this is one of your actual germanium transistors, okay, much talked about, and if you compare it to a modern silicon transistor, I don't think you can see that, we can see one here, look, this fella here, it's got 3 legs, same as the old germanium things. But it's in a plastic case rather than the metal case, metal can that these are in. What can I tell you about them? Well, people have been working all through the 30s and 40s on the idea of transistors. People were already well aware of this semiconducting effect that certain crystals had, particularly things like lead sulfide, which was used in the old cat's whisker radio sets. But really things started to get kind of serious in the late 40s and early 50s when 3 guys, William Shockley, Walter Bratton and John Bardeen, came up with the first thing that we'd really know as a modern transistor. It's just a thing called a bipolar transistor. That doesn't mean it suffers from, you know, kind of wild mood swings or something. It's to do with the types of junctions that it uses. Anyway, they were using crystals of material called germanium, which is quite rare. And that was the first one they managed to get kind of pure enough to create this a a sort of production quality workable transistor, and they started manufacturing these transistors in about 1954. Okay, and that's about the same sort of time as well the first transistor radios came along. Things took off pretty quickly for transistors. The Japanese company Sony as well then started producing transistors, and things really kind of took off anyway. So yeah, germanium transistors, invented largely, it's a fella, William Shockley, that's credited with it, but actually it wouldn't have happened if it hadn't been for his other two guys that really knew how to engineer this thing. Shockley, by all accounts, was a pretty obnoxious person who had very difficult relations with his staff. In fact, when he tried to set up his own company, 8 of his top people just left. They just couldn't get on with him, and they set up a company called the Fairchild Semiconductor Corporation in Palo Alto in California, and that is what became Silicon Valley. That was the birth of Silicon Valley, and yeah, the rest is history. Anyway, yeah, he's heavily into eugenics as well, Shockley, which is the science of why kind of one race is better than another race in his eyes, and the eyes of eugenicists. So yeah, by all accounts, a pretty unpleasant person. But anyway, that's enough of that. So yeah, they're your small signal amplifiers. Down here you've got your power transistors, big power transistors. Okay, now these haven't really changed much. This is a modern silicon transistor, the sort of thing you'd find in a lot of high power transistor amps and jukeboxes, that kind of thing, you know. So that's really giving you your power, and this thing puts out about 45 watts. Then we move through an output transformer just here. This one's still got an output transformer, though a lot of valve amps, a lot of transistor amps, you don't necessarily need to have them depending on how you've designed the circuit. Anyway, we come out of that, and then we're off to a couple of 10-inch speakers over here. Quite sweet, these speakers, actually, they sound nice. Let's have a quick look, see if I can move this around without breaking anything. Let's try and have a look underneath. Hang on, let me get this. Chris, don't watch this bit. Abuse your amplifier. Okay, so you can see in the back here, we've got one of the major pillars of modern electronics in place at this point, which is semiconductors and transistors. But the other big pillar that we don't have present yet is the printed circuit board. Okay, so everything is still point-to-point wiring in the back here. Much like you've seen an AC30 at the time, or a Marshall or a Watkins, that kind of thing, you know. All point to point, bit of lacing in there as well. This amp has had a problem with its tremolo circuit, like somebody just basically removed half of it for some reason best known to themselves. So that's been what I've been doing, is cleaning it up, servicing it, and then getting that tremolo circuit back up and active again. That's in there. Really, I think that's what I've got to tell you about the inside of it. Let's leave it there for now, and let's get his pants back on and have a look, have a listen to what it sounds like. Thanks for coming back. We've got the amp back in its enclosure now. So tell you what, let's put some power on it and just have a listen and see what this thing sounds like. It's a little bit noisy. Got that kind of hiss there, which is not uncommon in old transistors. Valves, actually, apart from the hum, the mains hum you get with valves, they're actually very low noise items. Whereas transistors, you get a lot of heat in transistors, a lot of heat actually within the semiconductor, and that gives rise to something called Johnson noise, which is the sound literally of the atoms vibrating, you know, in the crystal matrix, and that creates noise. Anyway, let's have a listen to this thing and see what it sounds like. So what we got? Very clean sound. We're on about 2 at the moment. This is a real loud amp. It is extremely loud. That's a good 40. You get a good 45 watts out of this, easy. You got bass. I've got bass and treble flat out at the moment. Usual stuff. Actually a bad sound, especially if you're looking for a sort of jazzy kind of clean sort of tone. Yeah, and if you're looking for that sort of, you know, the kind of it's going to keep delivering, you know what I mean? It's, you can turn it up loud, and that you're going to get that. It's not going to distort up. It's you know, I think it's an alright sound myself. I think it's good. I think a lot of it is these nice little speakers in here. Just giving it that. Anyway, you've got some other stuff in here. We've got vibrato, tremolo, whatever you want to call it. It's not the most deep, effective tremolo in the world, but it's alright, you know. You know, it's going to do you all right at your, you know, at your teenage supper club ball sort of thing, you know. Speed. Not a huge amount of variety there in the speed, but you know, yeah, it's a nice amp, I think. Anyway, yeah, I think it. You know, I can see really why people bought these at the time. I really can. Anyway, I think really, if we're going to do this justice, let's get it on properly. Let's get the Watkins copycat going. Thanks for joining us, and I hope you enjoyed looking at the Burns Orbit 2, and you know, we'll be back soon, and until then, keep watching the stars. See you again soon. Take care. Bye bye.